Hello students, today we are going to discuss analytical treatment of interference. So for this we are going to draw a ray diagram, a simple ray diagram. Suppose that you have a source like this, okay, and the rays of light are, as we have already studied in the Huygens principle, okay. So these wavefronts are emanating from this particular point source, and we have two pinholes like this, okay. My diagram may not be that perfect. So after these things are coming, these wavefronts are incident on this particular screen having two pinholes, and what will happen that it is going to produce secondary wavelets like this, okay. So in a waveform of wavefront we are drawing like this, okay. So and then we have a particular screen here, and on which we are supposed to have the some kind of, we are supposed to observe some kind of interference pattern. So that suppose that the ray of light coming from this pinhole is incident on this, I will name it as S1, and this is as S2, and another pinhole, it is being incident here like this, okay. So this is the point we have. So again we have this, we are just drawing a reference line in the middle. So this is the point O, this is a center, and so in this diagram what we have done, let us consider that a monochromatic source of light is light S is emitting waves, and S1 and S2 be the two narrow pinholes, and they are equidistant from S, okay, the main source. The waves arriving at S1 and S2 will be in phase all the time, fine. So now let us suppose that now we are going to consider that displacement the displacements of the two wave are given by, so first wave means from S1, okay. So this A1 sine omega t, I will where omega is a frequency, okay, angular frequency, and y2 is equal to A2 sine omega t minus delta, okay, where delta is the phase difference between S1 and S2, okay. So you can consider it as S minus and plus, it's up to you, it's not a problem, okay. So we just want to say that delta is a phase difference, so it can be either minus or either plus. So let it be equation number 1, and it is the equation number 2, and then we know that here the phase difference, okay, phase difference, delta is a phase difference, it is always written as twice pi by lambda into path difference. We should always remember this formula, okay. So this is a kind of information that we also should get. Again, where A1 and A2 are the amplitudes of the wave coming from S1 and S2 respectively. This note has already been provided in Google Classroom, so you can easily relate it to it. So now as per, according to the principle of superposition of waves, you see, one wave is coming from S1, another wave is coming from S2, and they are meeting at the point P. At this point P, two waves are getting superimposed, okay. So this is nothing but the phenomenon of interference, fine. So according to the phenomenon of interference, that is the superposition of two waves, the resultant amplitude will always be the addition of the amplitude, resultant displacement will always be the addition of the algebraic sum or addition of the individual displacements by the individual waves, okay. So S1, the wave coming out of S1 has an resultant displacement of y1, and another one has a resultant displacement of y2. So y is equal to y1 plus y2. This is as per principle of superposition of waves. Now it is a1 sine omega t, a2 sine omega t plus delta. Okay, so after that we are simply going to do some mathematics. So sine omega, a1 sine omega t, then a2, so it is sine omega t, sine a plus b formula, everyone knows it. So cos delta plus sine delta cos omega t. All right, so it is a1 sine omega t plus a2 sine omega t cos delta plus a2 cos omega t sine delta. So further simplifying, what do we have? So we can take sine omega t common from both this term. So it will be a1 plus a2 cos delta plus cos omega t. What remains? a2 sine delta. So this thing we can represent in one another form. Sine omega t can be written as cos theta plus cos omega t. a2 sine delta means r sine theta. Okay, so this is resultant y or resultant displacement. So it is r sine omega t cos theta plus cos omega t sine theta. Okay, so it is nothing but r sine omega t plus theta. So this is the resultant amplitude. Okay, so let it be our equation number 3. So here where what we have written, that r cos theta is equal to a1, see this one, a1 plus a2 cos delta. Okay, I think we have written, and r sine theta equal to a2 sine delta. Okay, so therefore we can square this thing and this thing. So it will be r square cos square theta plus r square sine square theta will be a2, sorry, will be a1 plus a2 cos delta square and a2 sine delta square. So it is r square cos square theta plus sine square theta is equal to a1 square plus a2 square cos square delta plus twice a1 a2 cos delta plus a2 square sine square delta. So this thing is 1, so it remains r square equal to a1 square. You can see that a2 square cos square delta and a2 square sine square delta, it will be simply a2 square plus twice a1 a2 cos delta. So therefore r is equal to root over a1 square plus a2 square plus twice a1 a2 cos delta. Okay, so that's what we have for the resultant. So r is a resultant amplitude. Okay, and therefore resultant intensity is nothing but square of the resultant amplitude. So it is nothing but intensity is nothing but A1 square plus A2 square plus twice A1 A2 cos delta. So these are the important formulas. Okay, so here you can see that A1 is the resultant amplitude, individual amplitude of the first wave, A2 is the individual amplitude of the second wave, and R is the resultant amplitude. Fine. Similarly, Y1 is the individual displacement of the first wave, Y2 is the individual displacement of the second wave, and Y is the resultant displacement of the final wave. Okay, so this is the thing, and as per that we have got the formula for resultant amplitude and resultant intensity. Okay, now we need to find out, as I told you, that what is meant by, what are the conditions for, first of all, constructive interference. Okay, so here you see R, we need to take care of the intensity. Okay, intensity is equal to A1 square A2 square twice A1 A2 cos delta. Okay, now if you want to make resultant amplitude, constructive interference means the interference should be maximum. Okay, so, or you can see that the amplitudes, resultant amplitude should be addition or should be greater than the individual amplitudes of the single waves. Fine, that means if you want to make I equal to I max, here you see this thing should be equal to what? Cos delta. So whenever we talk about cos theta, if you say 180 degree, okay, 90 degree and 0 degree, cos 180 degree means it is -1, cos 90 degree means 0, means +1. Okay, so that means cos theta value can vary between -1 to +1. Maximum it can become +1, minimum it can become -1. So if I has to become I max, cos delta must be equal to how much? +1. Then only it will be a plus sign, it will be addition. So that means I equal to I max only when cos delta equal to +1. Okay, cos delta will be +1. Then what happens? I max will be equal to A1 square plus A2 square plus twice A1 A2. So it will be A1 plus A2 whole square, A plus B whole square formula. So you can see that the amplitudes are added. Okay, so it is nothing but R square, isn't it? So R is equal to A1 plus A2. So this is constructive. Fine. So we need to find out. So cos delta equal to +1 means delta is equal to, you know how much it is? Twice n pi. Okay, so twice n pi. So delta means twice pi by lambda into, because delta is nothing but the phase difference, and as already we have written, phase difference means twice pi by lambda into path difference is equal to twice n pi. Okay, so pi gets cancelled. So path difference for constructive interference, 2 also 2 gets cancelled, equal to n lambda. So you can, or you can simplify it like this, path difference is equal to twice n into lambda by 2. So this is n, you can say that this thing is an even multiple. 2, if anything you multiplied by 2 will be an even number. So it is called even multiple. of lambda by 2. Okay, so to form a to get a constructive interference, okay, constructive interference, whenever see, that means it is a bright fringe. Okay, you are going to get a bright fringe, it's not going to dark. Okay, so bright fringe, so amplitude or intensity will be brighter. Okay, so it is not going to reduce, it will be added. So but for having a bright fringe in an interference, that means to have a constructive interference, the path difference should always be an even multiple of lambda by 2. So that is the condition. Similarly, for destructive interference, that means to have dark fringe, means the individual intensities will not add each other, they will they will counter each other. Fine, suppose if you have 5, okay, and 5, fine, sorry, let me if you have 5 and 4, so if you add them, it will be 5 plus 4, 9. But if you have 5 plus, and if it is minus 4, it will be how much? 1. So whatever with this individual strength of the waves, here it will be more brighter. Here the individual strength of the waves is, one is 5 and one is 4, but when they add up, they will be opposite to each other, so they will not brighten each other, they will in fact counter attack each other, so it will be a weaker view, so it will appear darker and it will appear brighter. So this thing is called destructive interference and this thing is called constructive interference. So here they are not adding up each other, they in fact even acting in a negative way. Okay, so they are destroying the another amplitude, resulting in a even lower amplitude, lower magnitude of the amplitude. So if that will happen, I will become equal to I mean. Okay, see, I was equal to a1 square plus a2 square plus twice a1 a2 cos delta. Okay, as I say that cos delta either can take plus 1 or I can minus 1. So to reduce the value, it should be equal to how much? Minus 1. So only when cos delta is equal to minus 1. Okay, so what will happen here? I mean will be equal to a1 square plus a2 square minus twice a1 a2. Okay, so I mean is equal to a1, so it is like something like a minus b whole square, so a1 minus a2 whole square. See, they are subtracting, they are getting subtracted, so obviously the final value is not going to be a bigger value, it is going to be a smaller value. So that's why the amplitude is going to be reduced, the resultant amplitude will be even smaller than the individual amplitudes. So this is called I mean. Fine, so this happened because cos delta is minus 1 and delta will be then equal to twice n plus 1 pi. So this is already the phase difference. So already we have done twice pi by lambda into path difference, we are converting into path difference. So path difference is equal to twice n plus 1 pi. So pi gets cancelled. Okay, so path difference is equal to twice n plus 1 lambda by 2. So this thing, you see, this is an even number, plus 1 means it is an odd number. Okay, so that means it is always a odd multiple of lambda by 2. difference of this odd multiple of lambda by 2. So these are the two situations. So first thing, the condition for constructive interference is that the path difference should always be an even multiple of lambda by 2, and we have proven it. In exam you may be asked to prove that for constructive interference the path difference between the interfering waves should be equal to even multiple of lambda by 2. Similar can be asked for the for destructive interference. That means they prove that for destructive interference the interfering wave should have a path difference equal to odd multiple of lambda by 2. So that's all for the analytical treatment of interference. I have already shared the note in Google Classroom along with some graphical representation and some images which will make it much more clearer for you to interpret this video lecture.